In this video, we are going to learn basic proportionality theorem in 3 simple steps. The statement of the theorem says, if a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points, the other two sides are divided in the same ratio. So what is given to us? Given a triangle ABC in which a line is drawn parallel to one side of the triangle. So DE is drawn parallel to BC. And what I need to prove? I need to prove that the other two sides are divided in the same ratio. That is AD by DB is equal to AE by EC. This I need to prove. So in this we need little construction which says we need to join BE and CD and draw perpendicular DM to base AC and EN to base AB. So we need to learn these steps. We need to learn that which type of construction we need to do in this. Then it will be done in 3 easy steps. The first step is we need to look into the triangles, this orange one and this green one, which is triangle ADE and triangle BDE. Now area of triangle ADE, we already know that area is half into base into height. So for ADE, AD is the base and to this base perpendicular is EN. Then for BDE, base is BD and perpendicular is again EN, because how we can draw the perpendicular to the base? If base is BD, the opposite vertex is E only for this, and from E perpendicular is EN. So for base BD, for this triangle as well, for base BD the perpendicular will be EN only. So this will be half into DB into EN, that is half into base into height or perpendicular. So half and half will be cancelled and EN and EN will also be cancelled, and we will get AD by DB. Now step 2. In step 2, we need to look into these two triangles ADE and DEC. The same thing that we did with those two, we need to do with these two as well. Area of triangle ADE. Now this time we need to consider base as AE, because we are talking about this triangle as well, and for this base is EC. So that is why we need to consider this side this time. So AD, base is AE, perpendicular is DM. So area of triangle ADE is half into AE into DM. Similarly, area of triangle DCE, the base is CE, same, the perpendicular will be DM, as the vertex opposite to EC is D and the perpendicular drawn from D is DM to the base EC. So half into EC into DM, and we will get AE by EC here after cancelling these. Now step 3. Step 3 says about these two triangles. These two triangles are there, this triangle and this triangle. As these two triangles are on the same base DE and between the same parallel lines, there is a theorem which says that if two triangles are drawn on the same base and between the two parallel lines, then their areas will be equal. So area of these two triangles will be equal. So 3 things we have done in this. We have find the ratio of area of triangle this by this, then area of triangle this by this, and in the third step we have equated these both areas. So you can see that in the first step we got AD by DB, in the second step we got AE by EC, and in the third step we have got that their areas are equal. Now you can carefully look into 1, 2 and 3. In step 1 numerator is ADE, in step 2 as well numerator is triangle ADE. Now their denominators are different, but here in step 3 we have proved that they are equal. So you can see that left hand side of these two are equal, right? If left hand sides are equal, then right hand side will also be equal. So we can write it as by 1, 2 and 3 AD by DB is equal to AE by EC, hence proved.